2.2, circles. Now a circle is a set of all points in a plane that are equidistant from some given point. Or we could say a given distance from a given point. That given distance is called the radius, and that given point is the center. Now if we call that center the point HK, and the radius R, thus creating a circle, we can write the circle equation in center radius form. And that form comes from the distance formula, the distance between 2 points, because as we said, the distance between the center and each point on the line is the same. It's the set of all points that are equidistant from a given point, the center. So if the center is HK and any given point is denoted as XY, then the center radius equation can be written as x minus h squared plus y minus k squared equal to r squared, where the center is HK and the radius is r. Now a special case of this would be when the center is at the origin. When the center is at the origin, you can see that h and k would be zeros, which puts us into the form x squared plus y squared is equal to r squared. So a much more simplified form if the center is at the origin. What if it's not at the origin? Well, let's try an example. I'm going to get this out of the way. We don't need that. But we're going to keep those equations off to the side. If we have a circle with a center at negative 3, 2, and a radius, and I will point out that the radius always has to be greater than 0, a radius of 5, then according to the center radius form, we can write the equation as x minus negative 3 squared plus y minus 2 squared is equal to 5 squared. Simplified, we could make that x plus 3 squared plus y minus 2 squared is equal to 25. Now what if we wanted to plot the circle? Now obviously there's an infinite number of points that could be plotted, so what's the simplest way for us to plot this? Well really, it's a matter of finding the center and then using the radius to go in the 4 easiest directions, which is go to the right by the radius, go to the left by the radius, go up by the radius, and go down by the radius, and then just doing our best to draw a curve that goes through those. Now, I will point out when you're trying to draw your circle, obviously that was not done perfectly due to the fact that I did not do any measurements. But notice that even as such, it looks circular, as opposed to the common circular drawing that does not look circular at all. The key to making it look circular is to realize that when you're passing through the top point and the bottom point, that you're passing through horizontally. You're passing through like this. And when you're passing through the right and left points, you're passing through vertically. If you watch for that and do your best to make sure that's what happens, then your circle will come out much more circular. But that's the easiest way to plot that. So if I have this right here and I want to plot this circle, I'm going to create my grid. Give myself some numbers, 2, 4, 6, 8, 2, 4, 6, 8. Remember, you always want to number your axes. -2, -4, -6, -8, -2, -4, -6, -8. Now, it would not be a bad idea to get yourself some graph paper or go on to one of the many sites on the internet that allows you to print out graph paper, because when you start plotting a lot of these things, yeah, I can make it look reasonable writing this. I've also spent many years drawing these grids, and so in general I can make it look somewhat reasonable, but it's going to be much neater and easier to do it if you've got graph paper. Not a requirement, but just a suggestion, because it doesn't take much of a slanted axis or not getting your indices set up right where things start looking very strange. So now, the first thing I'm going to do is plot my center, which is at -3, 2. So -3, 2. There's my center. And then to create my circle, I'm going to use that radius of 5. So -3 plus 5 is +2. -3 minus 5 is -8. So I have my two side points, and then 2 plus 5 is 7, and 2 minus 5 is -3. So now that I've plotted those points, I can come and make my circle. Which, even coming from an angle and being sloppy about it, that doesn't look too bad. That actually looks kind of like a circle. So that's our method. Pretty straightforward. If we know the center and the radius, we can create the center radius form of the circle equation just by doing h minus k squared plus y minus k squared equal to r squared. And when it's in that form, it's really easy for us to pull out the center and the radius, because looking at this, we go, okay, -3, 2. The radius is the square root of that, or 5. So it makes it pretty straightforward. Even simpler if the center is at the origin, then x squared plus y squared is equal to r squared. Sometimes we're not given the center, we're not given the radius, and we're not given an equation in center radius form. I'm going to leave that up there for a moment. So what do we do in that case? Well, there is a general form for the equation of a circle. And that is, so I'm going to put that as general form over here. X squared plus y squared plus cx plus dy plus e is equal to 0. So that is a general form. As with, you could even say as with linear equations, when you have a general form, it's not always the most informative, just to look at it, but you can manipulate it to turn it into what you need. So what we're going to do is we're now going to complete the square twice on this equation. Well, what do I mean by completing the square twice? Well, we're going to complete the square for the x's, and we're going to complete the squares for the y's, but all in here at the same time. So I'm going to change this to x squared plus cx plus y squared plus dy is equal to negative e. Well, why did I do that? Well, remember when you're completing the square, what you want to do is put the constant over the other side. First thing you do is you check and make sure that your leading coefficients are 1. We already, in this case, we already have that. We don't have a variable in front of it. If we don't have that, if this had a some constant in front of it, then we would have to be the same constant, and we'd have to divide it out just like you would in completing the square normal. So we've got this far of it, and we move the constant term over to the other side. Well, if we're completing the square, we're going to take half of the x coefficient, so this c, and square that to get the other term. So we got x squared plus cx plus c over 2 squared. And then we're going to do the same thing for y, plus y squared plus dy plus d over 2 squared is equal to, well now, since we added c over 2 squared to this side and d over 2 squared to this side, we've got to do it to the other side. So minus e plus c over 2 squared plus d over 2 squared. Now that we have that, that's a perfect square. So that's x plus c over 2 squared plus y plus d over 2 squared is equal to, and I noticed something here, I see that I've got squareds and I've got 2's down here, so I can make this minus e plus c squared plus d squared over 4. I used the power rule and said c over 2 squared is the same as c squared over 2 squared, and d over 2 squared is the same as d squared over 2 squared. 2 squared is 4. So a common denominator of 4, leaving me with c squared plus d squared over 4. And if I take this one step further, I can say that x minus negative c over 2 squared plus y minus negative d over 2 squared is equal to negative e plus c squared plus d squared over 4. And now what I have done is I have just put this into center radius form. X minus some value h plus squared plus y minus some value k squared is equal to r squared, but I'm not going to call it r squared. What I'm going to say now is that if we start out in general form, then h is equal to negative c over 2, k is equal to negative d over 2, and m is equal to negative e plus c squared plus d squared over 4. And yes, I could take that further if I wanted and put this over 4 also, so I make it minus 4e plus c squared plus d squared, but I'm not going to do that. Now the reason I didn't just call this r squared is because 3 things can happen when we start with an equation in this general form. 1, if m is greater than 0, then m is equal to r squared. So if m comes out to be greater than 0, then we are dealing with a circle with a radius that is the square root, or so I'm going to take this one step further. R is equal to the square root of m, just to clarify that, where the radius r is equal to the square root of m. If m is equal to 0, then we have no radius. We have a radius of 0, which means that we have the equation is just a point. And if m is less than 0, then it's non-existent. Meaning there is no point that fits that equation. So given an equation for a circle in general form, we have a couple options. We can either go through and complete the square twice to find out the center HK and if there is a radius and what it is, or we can use these equations which came from completing the square. Remember, the quadratic formula came from completing the square also. So it's nothing new to us seeing something like this. So we just completed the square twice to get this ability. So I'm going to get rid of this blue stuff because we don't need it anymore. Since we have all the, the red stuff since we don't need it anymore. Since we have all the stuff in blue, that's going to help us out. So let's put up an equation in the general form and see whether it's a circle, and if it's a circle, what its radius is. X squared plus 4x plus y squared minus 8y minus 44 is equal to 0. So we have an equation. It's almost in general form. Right? To put it in general form, we want to put it x squared plus y squared plus cx plus dy plus e equal to 0. So I'm just going to shift it around a little bit. The reason we want to do that is we want to make sure that we use the right coefficients to plug into our equations over there. So that's x squared plus y squared plus 4x minus 8y minus 44 equal to 0. So we can find the center by finding h is equal to negative c 4 over 2, which is negative 2. K is equal to negative d, that's negative 8, over 2, which is equal to positive 8 over 2, or 4. So we have a center at negative 2, 4. And now we want to calculate m, so we can determine whether it's actually a circle, a point, or non-existent. So m is equal to negative, e was negative 44, so negative 44 plus c squared, c was 4, so 4 squared plus d squared, which is negative 8, over 4, which is equal to 44 plus 4 squared is 16. 16 plus negative 8 squared is 64. 4 over 4. 44 plus 16 plus 64 is 80. 80 over 4, so 44 plus 80 divided by 4 is 20. 44 plus 20 is 64. So m is greater than 0, therefore we do have a circle. So I'm going to state that right now, it's a circle. It has a center at negative 2, 4, and r is equal to the square root of m, so the square root of 64, which is 8, so radius is equal to 8. So we started in something close to general form, put it into general form, and then used our little formulas over here to work our way through. Could we have completed the square twice to get this? You bet we could have. And it would work. Would it be a little more effort? Well, it depends. Can you remember these formulas? I can't. So if I don't have them written down somewhere for me to look at it, I'm going to be completing the square twice. But I know how to complete the square, so that's not a problem. If you can remember these formulas, then by all means, use those formulas. Just be careful because one sign change somewhere or a wrong number throws everything off. So beware of that. But we can take it, so now we've got center radius form, we've got general form. Give me the equation of a circle in either of those. I can give you the center and I can give you the radius. Or if you give me the center and the radius, I can give you the center radius form for the circle. And if I really had to, I could work my way backwards to that too, because it's just a matter of squaring this, and doing the calculations to bring it over to the other side. So I can convert from general form to center radius form, and from center radius form to general form. With a little effort, but it's not that horrendous a process. It's stuff that we've done before. So that is our introduction to circles.